Let's prepare on open channel flow. So now we are going to see about the open channel flow. So when the flow of the fluid is in open channel means bottom surface alone will be there, the top portion will be open to atmosphere. So that type of flow we will be going to see now. So this is the very important topic out of this fluid mechanics itself in respect of this competitive exams, because at least one question will be asked definitely from this chapter. So first let us see. The flow subjected to the atmospheric pressure is called open channel flow. So as I told you already, the surface will be there, any surface. It may be a lined canal or unlined canal. Unlined canal means it is a natural canal will be there. No? So surface will be there and the water will be running there. So the top portion is open to the atmosphere. So what happens? The pressure of that fluid will be equal to the atmospheric pressure only. So this only we call it as the open flow channel. So here you can see the difference between the open channel flow and the pipe flow. So here it is the respective of atmospheric pressure, but whereas in pipe flow the fluid will be experiencing either pipe pressure, that is either negative or positive also. That depends on the pipe, because we can send the fluid in the negative pressure also. So this is the basic difference between the open channel and the pipe flow. So here I have drawn the HGL and TEL. So this we have already seen, hydraulic gradient line and total energy line with respect to both, that is open channel here and the pipe flow here. Okay, so here we have already studied what is HGL. It is nothing but the summation of the pressure head and datum head. Okay, so when you add the velocity head also with that, we will be getting the total energy line. So it will be always higher than that. The same thing only in the case of pipes also. But there is an important point to be noted here. The basic difference is nothing but the HGL here in the open channel flow coincides with the water surface. How means? We know that HGL is nothing but the pressure head plus datum head. So what is pressure head? It is P by rho G. But we have already seen the fluid that is flowing in this open channel is having the atmospheric pressure in it. So when it is having atmospheric pressure, the P will be equal to 0. So this total pressure head term will be equal to 0. So what happens? Only datum head will be there and hydraulic gradient line will be drawing with the datum head. What is datum head? It is respect to the height of the water. So what happens? The top surface of that water and the hydraulic gradient line will coincide and lie in the same place. So this is the property of this open channel flow. Whereas in the pipes, we will be having hydraulic gradient line above a certain height, and above that only we will be getting the total energy line. In some cases, hydraulic gradient line can be bottom to that and top to that also, because we have already seen the pressure may be positive or negative in the pipe. So when it is positive or negative, the HGL may be changing with respect to that as below or above the total energy line. So this is the basic thing you should know between the open channel flow and pipe flow. The next thing we are going to study is how the variation of velocity happens in the open channel flow. So now only the previous chapter only we have studied about this pipe and velocity variation in the pipes and between two plates like that on. Okay, but here in open channel flow, it cannot have two places of zero velocity, because it is open on the top. So it will be having zero velocity at the bottom alone, and it will be enlarging with respect to the height of the fluid that is passing over the fixed surface. So here this is the velocity profile of this fluid that is passing through the open channel. So here if you take means, this will be your highest velocity, and the maximum velocity that is occurring is at the point of 0.2 times the y only. It is not at the y, it is from top. I have drawn here in the sides 0.2 times the y. So in general the range is between 0.05 y to 0.25 y. So these are very important. They will be asking in the exam. So this is the range where generally the maximum velocity occurs, and mostly we will be using this value, that is 0.2 y will be the maximum velocity, like that we will be using. And minimum velocity is at the at the distance of 0.8 y. Okay, so it is here at the 0.8 y only you will be getting the minimum velocity. And average velocity, we are just taking the average of these both, so you will be getting velocity at the point of 0.6 y. So these 3 points are very important. So here the velocity diagram, no distribution, it is expanding in a logarithmic way, whereas in the previous chapters we have studied, no, velocity will be experiencing a parabolic variation and shear stress will be experiencing a linear variation. But here this velocity distribution in open channel will be experiencing a logarithmic variation. So this is very important. And we have already seen in pipes means it will be parabolic, laminar flow. If it is a turbulent flow means it will be similar to a rectangular shape. So this is the variation of the velocity profile in pipes. The next thing we are going to see is the classification of open channel flow. So the first classification is based on the shape. So based on the shape of that canal or that surface, no, so it may be triangular, rectangular or square open channel or even circular open channel is provided. And the second classification is based on the cross section. So cross section means we categorize into prismatic and non-prismatic. Prismatic means it will be having a constant shape and size throughout the flow. In non-prismatic means it won't have a constant shape and size, it will be varying at certain points. For example, natural channel. So natural channel means it cannot be having a same length and same width along the flow, so it will be changing. So that is an example for non-prismatic open channel. And the third classification is based on the time. So we have already seen these concepts, unsteady flow, steady flow and all, no? So with respect to that also we can classify the open channel flow. So when there is no change with respect to time means we call it as steady flow. With respect to time, if there is changes means we call it as unsteady flow. And then fourth classification is based on the space. So here uniform flow and non-uniform flow. So when there is no change with respect to space means we call it as uniform flow. So here this velocity, discharge and even the height does not vary in any position. So it will be of uniform flow. And non-uniform flow means it changes with respect to space. So the examples given are gradually varied flow, rapidly varied flow and spatially varied flow. So these three will be studied in detail in this chapter. So these three are some of the examples for this. The next thing we are going to see is the steady and unsteady flow and the examples with respect to all these different categories. So this is very important because several times they have asked this in the exams. So the first thing is under the steady flow, the first example is given for uniform flow. So the prismatic channels with constant velocity. So what is prismatic channels? Channels with constant shape and size throughout the flow. And it is having velocity also constant. Then it will be definitely a uniform flow. The next example is a steady, gradually varied flow. So what is this gradually varied flow means? The changes in the depth of the flow will be gradual. So depth of the flow will be gradual. So the example here is the backwater curve behind a dam. So how this backwater curve behind the dam will be there means, if this is your dam structure and this whole area is your dam means, the water here may be like this, but it will be increasing accordingly like this in a gradual way. So this is an example for this gradually varied flow in steady condition. And the next thing is steady rapidly varied flow. Rapidly varied flow means the flow, that is the depth changes are very small but in large distances. So that is called as rapidly varied flow. So the example is given here is hydraulic jump at the toe of the spillway. So we will be having spillway like this, no? So when the water comes here, it hits the bottom and then it jumps, no? So at this point we call it as the hydraulic jump. So there will be a sudden change in the depth. So that is only called as the hydraulic jump at the toe of the spillway. And the fourth one is spatially varied flow. So spatially varied flow means it is the change along the length. So change of the depth of that flow along its length. So the example given here is the flow over a side weir. So how this will be means, here you consider this as a weir or something. Okay, so the water is moving like this. along its length it is moving. So when it is moving here, some water will be flowing in this direction also, and the remaining water will be going there. Okay, so here it may be of or discharge may be Q1, here the discharge may be Q2, and the flowing water through the side, no, so it may be of Q3. So there will be a change in the discharge. So this only it is called as the spatially varied flow, that is the sudden discharge that is occurring any side of the weir. And the next thing is the unsteady flow. So under unsteady flow also we have all these categories: gradually varied flow, rapidly, and spatially varied flow. So you may think why uniform is not given here like that. A uniform unsteady flow cannot be happen. It is not practically possible, so it cannot be given. So unsteady gradually varied flow, the example is flood waves in water. So the flood that is occurring in the river. And then rapidly varied flow means surge waves in canal or tidal bore in river. So here the surge waves in the canal is nothing but the higher waves, that is the higher height waves will be coming, no, so that only we call it as the surge waves. And the tidal bore is also similar to that only. So there will be a sudden waves created in the rivers. Sometimes it may be in the opposite direction of the rivers also, and this may occur in the point where the river and ocean will be mixing, no, so in that points some waves will be created. So this only we call it as this rapidly varied flow with unsteady condition. And the third is spatially varied flow. So an example is surface runoff due to rainfall. So the runoff due to rainfall we know, so it is called as spatially, it is varying spatially. Okay, so this is all about this gradually, rapidly, and spatially varied flow, and with respect to steady and unsteady. So these examples are very important, they will be asking you again. So here let me tell you a question. A flood wave while passing down a river section protected by embankments spills over the embankment at certain locations. Then the flow is classified as what? So they have given an embankment is given and a flood wave is coming. In some points it is overflowing. And what is that flow like that? So we know that floods means itself it is basically unsteady in nature. Okay, so we have seen this, no, flood waves in the river is unsteady in nature. So we have categorized into unsteady flow now. And the next thing you have to see is the spill of the discharge occurs in only some locations, that is the discharge along the length of the channel. So we have seen, no, the flow over a side weir. So side weir, where it happens, it will be located in some points only. So here also it is not given in the question that it overflows completely. It is overflowing in some points alone. That means it is overflowing through some side weirs. So it means that it is a spatially varied flow. Then the answer will be given as steady gradually varied flow, unsteady spatially varied flow, like that combinations will be given. So you have to choose the answer as unsteady spatially varied flow. So this is how they may ask you in the exams. Thank you, and keep watching for the next lecture on channel geometry.